Welcome to the online classroom for the module ECS3706, econometrics. This is the third level module, part of the economics module that students take, especially if they're majoring in economics for their degree program. So in these classes, I'm just going to be taking you through the learning units. The module has 11 learning units and is divided into 4 parts, with each part based on specific parts of the prescribed textbook, right? So what I'll be doing, it's a module that contains a lot of statistics, a lot of theory, and assumptions. And if you haven't done statistics, but if you're doing econometrics, you've probably done statistics before. But there are a lot of concepts that might seem a bit new to students. So my goal is to take you through those concepts. So what I'll be doing is I'll be taking you through the study guide and the prescribed textbook in turn. And the way this module is structured, I didn't think it's quite appropriate for me to create notes. Like I know you'll see with my other modules, like ECS3701, for example, that one, the prescribed textbook is quite big, and even the study guide, the way things are structured, so notes can help. But with ECS3706, I think I will just take you through the module, and as we go through, and as I'm speaking, giving you these lectures and these discussions, you can be taking your own notes, maybe writing them down. But it's not a module where you need to sort of rely on just notes. Like questions come in different ways. It's more a module about practice. So I'll be taking you through the module, explaining concepts to you. And the moment I explain and you understand and you practice, and you also take down your own notes, I think that will cement your understanding for the module, right? So that's how we are going to approach it. So learning unit 1 falls under part 1, an introduction to regression analysis, and it starts with an overview of regression analysis, right? So the first and most important thing that we have to understand with regards to econometrics is what exactly is econometrics. So it's probably the first time you are coming across this word, and someone might ask, what is econometrics, right? And when we talk about econometrics, we're just talking about an economic concept where we are attempting to estimate economic relationships. This is the goal of economics. It's just an economic concept whereby we are attempting to estimate economic relationships. Now, we know that in economics, there are a lot of relationships. We know there's price versus demand. We know there's this relationship that as prices go up, demand goes down. So this is a relationship, a theory, an economic theory. So we might want to put this economic theory into an equation, into a mathematical relationship. So that's what econometrics is all about. Econometrics is all about looking at economic theory, having looked at economic theory, looking at data, and then using that data and statistics to come up with an economic relationship between different variables, right? So econometrics models are really, really important, and they make use of 3 inputs, namely economic theory, economic data, and statistics. So I'm just going to explain this whole concept. So When we talk about econometrics, right, we're trying to estimate economic relationships, right? So how does this usually work? I'll start with a simple example. Let's say someone tells us that there's an economic theory, right, that says the level of expenditure in a household, depends on the total income of the household, right? So this is an economic theory that someone has told us. So what we do in economics, we look at this relationship, then we come up with a model, a mathematical model. So usually we use what we call regression. We're going to study regression in detail, where we would come up with an equation which says expenditure is equals to A, which is a constant, plus B, which is also a constant, multiplied by income. In other words, if we want to predict the expenditure of a household, we can take a certain constant plus another constant multiplied by income. So we start with an economic theory, then we come up with a mathematical model to try to explain that economic theory, right? And then after doing that, we come up with a mathematical expression. We then use econometrics to help us to predict the value of this coefficient and the value of this coefficient, and then we end up with an economic metric model. For example, our model might say A is equals to 2.1 and B is equals to 0.56. So we're going to look at how to do all those calculations, how to get those values of those constants and so forth, right? Right. So that's how econometrics has an input based on economic theory. Another input in an economic model is facts. It's facts. We might have historical data for different households. Maybe we have different households, and these are households have values which show their income and their expenditure, right? So that's the data. So we can take this data, then we can adjust it, and then we can use it to help us to predict these parameters. So one of the inputs in econometrics is firstly our economic theory, and then also our facts, which relates to the data that we use to help us to estimate the coefficients in our econometric model. And then lastly, we also use statistical theory as an input with regards to estimating our economic metric model. And with regards to statistical theory, we use certain statistical theory to help us to come up with these coefficients. Like we take the data, then we apply statistics to it to help us to come up with the values for these coefficients. So we call that parameter estimation. We are also going to look at that in detail. We also use statistics to do some tests called hypothesis testing, whereby we are testing if these parameters are really appropriate and significant for this given model. So we do a number of tests. So we take economic theory as an input, we take past data and facts as an input, and we also take statistical theory as an input. And then we group all of these items together, and they help us to come up with our econometric model. So that's what econometrics is all about, right? I'll just summarize. The goal of econometrics is to help us come up with an estimation of economic relationships in the form of an econometric model. We have inputs in economic theory, data, and statistical theory, just like this example. This was just one example that I took you through, and then we use that to get an econometric model, right? And then once we've got that econometric model, there are a number of uses we can put the economic model to. That's structural analysis, policy evaluation, and forecasting. So now that I've given you a high-level overview of what econometrics is, the inputs, the different facets, and the goals of an econometric model, the next thing I'm going to do, I'm now going to take you through each of these. I'm going to take you through what economic theory is, what it means, just briefly, also data, the different types of data we use when coming up with an econometric model. I'll also talk briefly about statistical theory, and then I'll talk about the uses of econometrics. So when we're looking at economic theory, that theory, that equation and that theory, that relationship between expenditure and household income was just one example of an economic theory. In economics, we have a number of different theories. For example, we have a theory relating price to quantity demanded. We can put that in a mathematical equation. We even have theories to do with consumption, private consumption, and how it's related to marginal propensity to consume, how the consumption function is related to private consumption income and the marginal propensity to consume. So what happens in economics, we always start with some economic theory. And then having started with that economic theory, we then always aim to put it in some form of mathematical relationship. There are many different types of mathematical relationships. It always doesn't have to be y is equals to a plus bx. We can even have log y is equals to a plus bx. And we call this the functional form. We call this the functional form. For example, y is equals to a plus bx is one functional form. The logarithm of y is equals to a plus bx is another functional form. There are many different functional forms, and we are going to look at the different types of functional forms. And basically what a functional form does, a functional form of an equation takes an economic theory and converts it into a mathematical relationship. So when we're talking about model specification in Learning Unit 7, we are going to talk about how to choose an appropriate functional form when you are looking at questions to do with estimating an econometric model. Another important concept to remember with regards to economic theory is that different people can come up with different economic theories, and they can then come up with different model specifications. But just because someone comes up with an economic theory, it doesn't necessarily mean it's correct, right? Someone can say income depends on expenditure. Sorry, someone can say expenditure depends on income, right? So someone can say this is the economic theory and come up with a mathematical relationship for this. However, expenditure might actually just depend on the GDP or the economic growth of a country rather than income. So someone else can come up with a different economic theory and rather say this is more correct than this. So people can come up with different economic theories and provide reasons for those theories. So you might find that when household expenditure was actually high, maybe it was actually because GDP, the growth of GDP was growing rather than income. So that's also a factor. And the study guide then looks at an example where in economics we have two theories or two schools of thought, where one school of thought was the monetarist school of thought, or the monetarist theory, which believed that Y, in this case, Y being income, is dependent on the amount of money. In other words, if we increase the amount of money supply, the income goes up. But now we have a new theory in which we have post-Keynesian, which actually believes that the level of money in circulation actually depends on money supply. So you can see these are just two examples. It's just an example of how one economists might come up with a theory where they say Y depends on M, whereas another economic theory might say M depends on Y. So econometrics is not black and white. Individuals come up with theories. These theories are put into mathematical relationships, and then we aim to come up with an econometric model. But an econometric model is not always correct. It's not always correct. There might be other factors which are actually affecting our variables, right? So that's important. So right now, I'm just giving you an introduction, but we're going to look at all of that. That issue with wrong model specification and economic theory being put into econometric models and the limitations of such is also going to be discussed in the later learning units. So that's really important. I'll give you an example of in fact, the study guide is a really, really nice example where they say, for example, someone might come up with an econometric theory where they say that I've noticed that people get married, right? People get married when they after buying a wedding ring, right? So someone might then say that since the purchase of wedding rings normally precedes marriage, marriages could be seen as being caused by the purchase. Okay, yeah. So this is the problem with some econometric models. Someone might say people get married when they purchase wedding rings. So we can conclude that wedding rings make people to get married. But this is not correct, right? It's not as simple as that. So it's called causality. I'll just read this. Like, let me just read this to help you to understand that a bit better. So econometrics depends on economic theory to provide the variables involved, the direction of causality and the nature of the functional form, right? However, econometrics cannot resolve the theoretical differences between the schools of thought, right? So causality depends only on theory. Econometrics can only determine correlation, which is the strength of the nature of the relationship. It cannot say anything about causality. Right. What we are being told here, we are being told that just because A happens, because B occurred, we can't say that B made A happen. Basically, that's what this paragraph is just saying. I'll repeat that. Just because A happens, because B occurred, we can't say that B made A happen, right? Just because a person got married after buying a ring, we can't say buying the ring made the person to get married. This is the idea with some faulty econometrics models. For example, we can say just because, let me give you another example, using the example I've been giving you all along. Just because expenditure in our household went up after there was a rise in income, it doesn't necessarily mean the rise in income led to the expenditure, right? Why? There could have been an inheritance that we received that led us to spending more. There could have been an economic boom in the economy where GDP growth rate went up and you had other investments in certain assets, and then that led to increased expenditure. So there are many, many different facets that might have occurred. You might have gotten married, and then as a household, your expenditure goes up. That's why sometimes when we construct econometric models, we don't just say that, for example, expenditure depends on income. We can say expenditure depends on income and GDP and whether you're married or you have children. So there are many different factors. So that's a really important concept in econometrics that tells us that Just because A happened after B occurred, it doesn't mean that B caused A to happen. So there's a nice example about the purchase of a wedding ring. So this idea of causality, this just depends on theory. If you say A is caused by B, there's a causality relationship. That's just theory, right? It's just a theory. So econometrics just takes whatever theory you give it, and it just comes up with these parameters, right? But we need to actually question whatever economic theories that have been given. Just like we saw the monetarists and the post-Keynesians questioning each other based on the economic theories that have been put through. So you can come up with any economic theory and there might be causality, and you can come up with correlations and come up with a model that appears good mathematically, but theoretically it's not correct. So we're going to deal with all of that. So that's with regards to economic theory. With regards to data, when it comes to data, like when we're doing econometrics, we use data. Sometimes we use what we call time series data. We use what we call time series data. Time series data is when you just look at data which has been measured over time in the past. For example, let's say we had an economic relationship where we said that GDP depends on a constant plus B, maybe multiplied by the level of interest rates, right? In this case, to help us to estimate A and B, we might go and look at historical values of GDP, maybe over the last 20 years, from 2000 maybe to 2020. Let's say we are working with this time interval. We can look at historical data from 2000 to 2020 for our GDP and also for the level of interest rates. Then we can use that data to help us to predict the parameters of A and B. The level of the data which will show our GDP over time, that's known as time series data. Even let's say we have our interest rates over time, it's known as time series data. And usually our regression model will then have something like this with a T, showing that the GDP at time T is related to A plus B times the interest rate at time T. So this would be data that has been collected over time. So we can then use that data to help us to estimate those parameters we were talking about. So we call that time series data. And then we also have data which is not time series data. If data is not time series data, we usually call that cross-sectional data. We call that cross-sectional data. Now, cross-sectional data can also be used in estimating regression parameters. Let's say we were using that model where we want to estimate expenditure, and we've said that it's related to our level of income. We can look at expenditure maybe for 20 households. Let's say we look at expenditure for 20 households in 2024 today. So we get 1 household, 2 household, 3, 4, and we look at the expenditure maybe in a given year in 2024, and we found that it's house at 200,000, maybe 400,000, maybe 100,000. And then we also look at their level of income, right? So this data is being taken at a specific point. It's being taken at a specific point in time. So we call that data cross-sectional data. That's called cross-sectional data, right? Because it's occurring at a particular point in time. And usually with cross-sectional data, we use a small I. So to say expenditure for household I, let's say we want to predict for a different household, is equals to A plus BI with a small I there with the income for household I. So usually in econometrics, we use either time series data or cross-sectional data to help us to come up with those parameters we use in the regression equation. So it's also important that sometimes we need to adjust our data, even if you have data before you use it. For example, you might have a price index which has a base year. If you want to use the consumer price index data for your regression model, even percentages, sometimes we need to convert data into percentages before we use it, and so forth. So I'm just explaining this. So sometimes even if we do have data, historical data, we want to help to estimate our parameters in our econometric model, we sometimes need to adjust the data, right? And then finally, we are also told that the types of data that we use in economic data is non-experimental. We just collect this data at a specific point in time, cross-sectional data or historical data. It's not data based on an experiment where we are experimenting and we record data. So this type of data where we are looking at historical data in the form of time series data and so forth, so cross-sectional data, that's non-experimental data. Right. And then finally, once we have specified our economic theory, the model that accompanies the theory, we've come up with the model using data with the cross-sectional time series data and estimated our parameters. We use statistical techniques to actually help us to do that. So statistical techniques such as regression analysis using that data and that economic theory helps us to come up with the values of these coefficients. We also do what's called hypothesis testing on these coefficients to actually test if these coefficients actually have the strength that they are assumed to have, and if our regression model is actually valid. So you'll find out that as we go through the course of econometrics, we are going to do tests, t-tests, which are hypothesis testing. We're also going to estimate the regression parameters. We won't be extensively deriving these estimators, but we'll be doing it simply, but the idea is more interpretation and understanding. So that's what we are going to be looking into, right? And then finally, for this class, let me briefly discuss the uses of our econometrics models, right? So we've said that we've got 3 uses, mainly. So yeah, just some examples of econometric models that are used in real life. You can just read up on this. Even the central bank, the South African Central Bank, uses an econometric model to forecast inflation. The Department of Finance uses an econometric model to forecast tax income. Commercial banks use econometric models to better understand how different economic sectors and industries might react to economic shocks. So they have many uses. Simple types of models may be used by business and industry for forecasting and planning. Even the Kleins link project referred to in the introduction aims to coordinate economic models to various countries to help forecast econometric trade and capital movements. So we've already had one of the most important uses of econometrics models is forecasting, like trying to predict we can look at GDP for the last 20 years and say, what's the GDP going to be maybe 5 years from now, right? So we can come up with an economic theory. GDP depends on interest rates, depends on the difference between imports versus exports, all those things, right? We come up with an economic theory. We put that in mathematical form, in the form of an equation, right? We look at historical data and we come up with parameters using statistics. And then we then use our model to help us to forecast what our GDP will be sometimes in the future, right? So forecasting entails a forward simulation of an economic model. So usually the assumptions made with the forecasting, for example, you take variables such as government expenditure, your economic theory will say these affect GDP, for example, or affect whatever item you're looking at. and then you feed them into your model to come up with your parameters, and then you can make predictions. But we'll also look at how to actually do this, right? So this is one of the uses of econometrics. But we always know that the past is always not a 100% guide for the future. But one of the important functions of econometrics is to help us to forecast based on based on our economic metric model. We also use econometric models to help us to evaluate policy evaluations, right? For example, the Reserve Bank might say, okay, we want to raise short-term interest rates by 1%, 100 basis points, or 0.5%, which is 50 basis points, and so forth. So before they decide, they might have three different options, maybe 0.5%, which is 500 basis points, 1%, which is 100 basis points, and 0.25%, which is 250 basis points. They can feed this into their econometric model, and then they can see that if we raise by 1%, maybe GDP is anticipated to grow by 2%. If we raise by 0.5%, GDP might grow by 3%. If we raise by 0.25%, GDP might grow by 1.75%, right? But however, inflation might also be affected and so forth. So they can then analyze different policies and say, okay, 0.5 GDP might go up by this amount, but inflation might end up being a bit higher, whereas here it would be less. So they can feed these values into the econometric models to see if they come up with a particular policy, how that will affect key economic theories. So that's one other use of econometrics or economic models. And lastly, we use econometric models to help us come up with structural analysis. Now, structural analysis is a bit tricky to understand, but I'll try to explain it as best as I can. I'll try to use a simple example, not as complicated as the one that we have here. I'll start with a simple one, and then we'll then look at. Let me start with a simple example so that you'll be able to understand this. Let's say the marks that you get in a test are dependent on the hours of study that you put in. So let's say your marks at time I are dependent on the hours of study. So let's say we use econometrics and we come up with, let's say we use regression based on data for different students, and we come up with a relationship which says MI is equals to 2 plus 0.8 H. Okay, so let's say we come up with this regression equation, which tells us if we want to predict the marks of student I at any particular time, we say 2 plus 0.8 times their hours of study. So structural analysis means we can get information from these particular values. For example, this 2 is telling us if you don't study at all, the minimum mark you are anticipated to get is maybe 2% or 2, right? And then this 0.8 is telling us for every 1 hour of study, your marks will go up by 0.8. That's what it's telling us. So basically, we've come up with a theory and then a mathematical relationship, and we've estimated parameters. And then these parameters, they actually tell us something. They have a structural interpretation to them. That's what structural analysis is. So econometric models also help with that. That's the same case, for example, here we're given the quantification of consumption, which depends on autonomous consumption and the marginal propensity to consume and the level of income. So if we actually do this calculation, right, we can get the value of C, and we can get the value of C bar and C, and we can interpret these, right? So now once you've calculated C, for example, that's a structural coefficient, and like they say here, it indicates the tendency of consumers to spend additional income on consumer goods and services, right? And then C prime is autonomous consumption. Yeah. So those values, they actually have an interpretation that actually has practical meaning. So that's one of the uses of econometric models. So I think we can stop there for part 1 of the classes. In the next class, I'll take you through regression analysis in detail. I'll explain what regression analysis is, what these coefficients mean. You really have to understand that. I'll talk about a simple regression analysis, and we'll also go to the prescribed textbook, where there are now some really important things with regards to estimating regression equations you need to be familiar with. And then we will be done with the first learning unit. So thank you very much for listening to part 1 of the discussion classes, taking you through ECS3706. I hope this class has been helpful. If you have any questions or queries with regards to anything covered in this class, or you need help with anything, please feel free to let me know. I won't always be able to get back to you promptly, but I'll always try to do so as soon as I can. Please remember, go through the class, think about the things that I've said, jot them down, take your own notes, interpret them. Feel free to ask me. Be engaged with your learning so that you understand as much as possible from what you are learning. So thank you very much and all the best.